Welcome to Sports Science Insight, the channel where we break down scientific evidence and turn it into practical knowledge for training, recovery, and human performance. Today we are looking at the article, Single Night Sleep Extension Enhances Morning Physical and Cognitive Performance Across Time of Day in Physically Active University Students. This randomized crossover study was published in Life in 2025 by Bouzouraa and colleagues. The main question is simple. Can almost 1 extra hour of sleep improve performance the very next day? In this study, the answer was yes. 1 night of sleep extension improved both physical and cognitive performance, especially in the morning. That is important because many athletes, students, and physically active people train or compete when the body is not fully ready. The morning can be a difficult time for performance because of circadian rhythm, sleep pressure, and lower alertness. But this study suggests that extending sleep by about 55 minutes may reduce part of that morning performance drop. A single night can change the next morning. And if you want more evidence-based breakdowns on recovery, sleep, performance, and sports science, subscribe to Sports Science Insight. Let's break it down. Sleep is not passive. Sleep is recovery work. During sleep, the body supports many processes that matter for performance. This includes tissue repair, neural recovery, cognitive processing, memory consolidation, attention, and readiness for the next day. Sleep may also support recovery through physiological processes, such as protein synthesis and hormonal regulation. But it is important to be precise. This study did not directly measure hormones or sleep architecture. It measured sleep duration, sleep efficiency, physical performance, and cognitive performance. The key idea is that better sleep can improve how the body and brain perform. For athletes and physically active people, that matters. Poor sleep can affect reaction time, fatigue resistance, motivation, coordination, and perceived effort. So sleep should not be treated as something separate from training. Training creates stress. Sleep helps the body respond to that stress. Sleep is not passive, it is recovery work. This study used a within-subjects randomized crossover design. That means the same participants completed both conditions. One condition was normal sleep, the other condition was sleep extension. In the normal sleep condition, participants kept their usual sleep schedule. In the sleep extension condition, they went to bed earlier with the goal of spending 10 hours in bed while keeping the same wake-up time. The researchers tested performance at 3 times of day. First at 8 p.m., which served as the evening baseline. Then at 8 a.m., which represented the morning circadian dip. And finally, at 4 p.m., which represented the typical afternoon performance window. The test battery included physical and cognitive measures. Physical tests included jumps, shuttle-run performance, balance, and medicine ball throw. Cognitive tests included reaction time and digit cancellation. This design allowed the researchers to compare performance at night, during the morning dip, and during the afternoon peak. Same participants. 2 sleep conditions. 3 times of day. The study included 24 physically active university students. There were 17 males and 7 females. The average age was 22.7 years. These were not elite athletes. They were physically active students who exercised at least 3 times per week. This is useful because many people watching this video may not be elite athletes either. They may be students, recreational athletes, coaches, or fitness professionals. The participants had good sleep quality at baseline. They also had neutral chronotype. That means they were not extreme morning types or extreme evening types. This matters because chronotype can influence how people perform across the day. The study also excluded people with sleep disorders, recent shift work, recent long-distance travel, smoking history, and other factors that could interfere with sleep or performance. So the study focused on a relatively healthy, physically active group, physically active students, not elite athletes. Before looking at performance, we need to ask an important question. Did the sleep extension protocol actually increase sleep? Yes. The study used wrist actigraphy to monitor sleep. In the normal sleep condition, total sleep time was about 476.5 minutes. In the sleep extension condition, total sleep time increased to about 531.3 minutes. That is an increase of about 55 minutes. So the title idea of 1 extra hour is close, but technically it was almost 1 extra hour. Sleep efficiency also improved slightly. Normal sleep efficiency was about 93.7%. Sleep extension efficiency was about 95.1%. This means the intervention did not just increase time in bed. It also successfully increased actual sleep time. That is important because performance changes should not be interpreted as coming from intention alone. The participants actually slept more. The intervention added almost 1 hour of sleep. Now let's look at physical performance. One of the strongest findings came from the 5-meter shuttle run test. This test reflects repeated effort performance and fatigue resistance. In the morning, after normal sleep, the best distance was about 93.3 meters. After sleep extension, it increased to about 102.8 meters. That is a meaningful improvement for a single night of extra sleep. The fatigue index also improved. In the morning, the fatigue index was about 21.2% after normal sleep. After sleep extension, it decreased to about 13.1%. Lower fatigue index means better ability to sustain performance across repeated efforts. The biggest practical message is that sleep extension improved repeated effort performance, especially in the morning, when performance usually drops. The study also found improvements at 4 p.m. for shuttle run outcomes. But the morning result is especially interesting because it suggests that extra sleep may help reduce the usual morning decline. More sleep improved repeated effort performance. The study also tested other physical performance outcomes. These included squat jump, counter movement jump, Y balance test, and medicine ball throw. Sleep extension helped several movement-related outcomes, but the effects were not identical across every test. For example, squat jump improved at 8 a.m. In the normal sleep condition, squat jump height was about 26.3 centimeters at 8 a.m. After sleep extension, it increased to about 28.2 centimeters. Counter movement jump also improved at some time points. Medicine ball throw performance improved in the morning and afternoon. Y balance results also showed some improvement, especially at 4 p.m. for the right limb. The key idea is that sleep did not only affect endurance or repeated effort. It also influenced tasks related to power, coordination, balance, and movement quality. However, the largest and most consistent effects appeared in more complex, sustained, or cognitively demanding tasks. So the message is not that every test improved equally. The message is, sleep helped movement quality, not just endurance. The cognitive results were also important. Sleep extension improved simple reaction time and attention performance. At 8 a.m., simple reaction time was about 296.4 milliseconds after normal sleep. After sleep extension, it improved to about 252.8 milliseconds. In reaction time tasks, lower is better. So this means participants responded faster after extended sleep. The digit cancellation test also improved. This test measures attention and processing speed. At 8 a.m., participants identified about 63.0 targets after normal sleep. After sleep extension, they identified about 67.6 targets. The study also found cognitive benefits at 4 p.m. This suggests that extra sleep may help the brain process information more efficiently during the next day. Cognitive outcomes appeared especially sensitive to the extra sleep. This matters for sport. Many sports are not only physical, they require reaction speed, attention, decision-making, visual scanning, and quick responses. The brain reacted faster after extended sleep. One of the most interesting parts of this study is the time of day effect. Performance is not the same across the day. Many people perform worse in the morning and better in the afternoon or evening. This is related to circadian rhythm, body temperature, alertness, and other physiological factors. In this study, performance was generally lower at 8 a.m. and better later in the day. Sleep extension did not erase circadian rhythm, but it reduced part of the morning performance drop. The authors reported that the morning to afternoon performance gap decreased by approximately 23% for simple reaction time and 18% for shuttle run best distance after sleep extension compared with normal sleep. That is practical. If someone needs to train, compete, take a test, or perform cognitively demanding work in the morning, extra sleep may help. It does not make the morning identical to the afternoon, but it can soften the dip. Extra sleep softened the morning performance dip. So what should we take from this study? First, adding about 45 to 60 minutes of sleep may improve next day performance. In this study, the actual increase was about 55 minutes. Second, the benefits were especially relevant in the morning. This may matter before morning competitions, demanding training sessions, academic exams, or cognitive performance tasks. Third, sleep extension improved both physical and cognitive outcomes. Repeated effort performance, fatigue resistance, reaction time, and attention all benefited. Fourth, this was an acute intervention. It was based on 1 night of sleep extension in physically active university students. So we still need more research on long-term sleep extension strategies, elite athletes, different age groups, and different chronotypes. Fifth, sleep quality still matters. More time in bed is useful only if it actually becomes more sleep. The final message is simple. Better mornings may start the night before. If this video helped you understand how sleep extension can improve performance, subscribe to Sports Science Insight. Here we analyze scientific evidence and turn it into practical knowledge for athletes, coaches, students, and sports science professionals. Leave your comment below. Would you try adding 1 extra hour of sleep before a morning competition or training session? Thanks for watching, and I'll see you in the next breakdown.